On page 708, quickly go through the vocabulary. Copy and complete. If a chord passes through the center of a circle, then it is called a diameter. Draw and describe an inscribed angle and an intercepted arc. Inscribed angle. Describe it. An inscribed angle has a vertex on the edge of a circle, on the circle, and its legs intercept another part of the circle. Describe how the measure of a central angle in a circle relates to the measure of the minor arc and the measure of the major arc created by the angle. We're not going to be able to write that here, so you can look up the answers in the back of your book. Okay, match the term with the appropriate segment. A tangent segment is LK, or KL. The secant segment is LN, and the external segment is, well, an example of an external segment is LM. Okay, find the value of the variable. And what they're looking for here is for you to recognize that these are two tangent segments, external tangent segments. Well, they have to be external if they're tangent, but anyway, and they're congruent to each other. All tangents that meet at a point outside the circle are going to be congruent. So, you're to see that they're congruent, and then you're going to write 9a squared minus 30 is equal to 3a. Now, immediately you should say this is going to be a quadratic equation because it has the a squared. So we're going to move everything over to one side of the equation so that it will be equal to 0. So we're subtracting 3a from both sides. Minus 30 equals 0. And you're going to have to factor this. Or you could use the quadratic formula. But we're going to factor this one. You might notice that all of these coefficients are divisible by 3, and to make the number smaller and easier to work with, we're just going to divide both sides of this equation by 3. 0 divided by 3 is 0. 9 divided by 3 is 3a squared. 3 divided by 3 is 1a minus 10. Now to factor this, you should already know that you're going to have two parentheses like so. And the first two terms have to equal 3a squared. So that would be 3a times a would give you 3a squared. It's the only way you can make 3a squared. You have a negative number here, so you have a choice of plus here and minus here, or the answer could be 3a minus something and a plus something. So I'm going to write them both down so we can look at all the different ways you might be able to do this. There's only one correct way though, so you've got to find that. All right? Now you've got to find two numbers that when you multiply them give you 10, which is your third term. And when you add them together, give you negative 1 because there's an invisible negative 1 there. It's minus 1a. Okay, there's an invisible negative 1 there. So, we're going to list all the factors of 10. There's 1 and 10. And we have to keep them in pairs because the pairs have to be used together. Okay, so it could be 1 and 10. But if we did that, we're thinking about how it would FOIL. So if you were to multiply 1 and 10 this way, you get a negative 30 and a positive 1. That's not going to work. Okay, so 1 and 10 is just not going to work because it's going to be the numbers too far apart to give you negative 1. 2 and 5 look like they won't work, except that when you come over here with 2 and 5 and you actually place them in there, let's put it this way. 2 and 5, that's 3 times 5 is 15, and negative 2 times a, which is negative 2a. That one doesn't work, but they're close enough that when you put them the other way, you get outer terms is 6a, and the inner terms are negative 5a. But we have a problem with that. When you put those two together, you get a positive a. We need a negative a. So we do need our 2 and our 3 paired together, so we're going to get 1. but we need our pluses and minuses in different ways, so this is not the correct equation. We're going to have to put the 5 here. Whoops. The 5 here and make it negative, and the positive 2a there. No, sorry. That's not right either. Put the 5 here where it's positive and the negative 2. There we go. Okay, now that is going to give us 3a times negative 2 is negative 6a, and 5 times a is positive 5a, which gives us our negative 1a in the middle. All right, now we have to set each of those equal to 0, because if either one of them is equal to 0, 0 times anything will give you 0. So we would say 3a plus 5 equals 0. We move our 5 to the other side, we get a negative number. Well, we know that can't work because you can't have a negative number for a distance. Okay, so that one is wrong. But a minus 2 equals 0. When we move the 2 to the other side, we get a equals 2, and 2 is possible. Now, if you plug it in to see if it works, we get 3 times 2 is 6. And then if you put 2 up here, you get 2 squared is 4. 4 times 9 is 36. And 36 minus 30 is 6. So 6 and 6. Okay, so let's go on to the next one. Okay. Once again, we're noticing that these are tangents, so they have to be equal to each other, and we get 2c squared plus 9c plus 6 is equal to 9c plus 14. So we're going to move everything over to one side. And when we do that, this one actually is going to work out better without doing the quadratic, because we can see that our two 9's are congruent or equal to each other. So when we move that 9c, it's going to disappear altogether. And so we're just going to go ahead and subtract our 9c from both sides and have it disappear. Okay, and then we're going to get 2c squared plus 6 equals 14. Well, now we can just move our 6 to the other side, and we get 2c squared, subtract 6, we get 8. Now we can divide both sides by 2 to get c squared equals 4, and then you can tell that c equals 2. Now, the square root of 4 is actually plus or minus the square root of 2, but remember we're talking about a real distance here, so it's going to have to be positive. Okay, so if you are working a quadratic and you have a variable squared, but your center term disappears, your 9c or your x or whatever it is, your x term disappears, then you can work it just by putting all your numbers on one side and your square on the other and taking the square root of both sides. Okay, this one says to find the value of the variable. And it says that z is a point of tangency. Up here it says z and y are points of tangency. So we know that this is a right triangle. And we're to find out what r is. And to do that, we're going to recognize that we have a right triangle, and we can use the Pythagorean theorem. Now remember, little man is right here, and this is the hypotenuse. So that would be our c side, and then either one of these would be a and b. And c is the whole thing, okay, in our right triangle. So I'm just going to redraw our right triangle and write again what our numbers are. Okay, now this whole side has a section called 3 and another section called r. So together they are r plus 3, or 3 plus r. It doesn't really matter which way you write it. Okay, so we're going to do a squared plus b squared equals c squared. So 9 squared plus r squared equals r plus 3 squared. Okay, now we're supposed to FOIL this, and you've maybe heard the term FOIL, but some of you have been having some difficulty with it. Okay, so one other way that you can do this is to stack them on top of each other, just 3rd or 4th grade. So if you have trouble remembering how to FOIL, this is a different way to do it. Let me see if I can find some space to write it. It's r plus 3 times r plus 3. So you could say r plus 3 and r plus 3. Now just 2 times 3, you're going to do the same thing here. 3 times 3 is 9. And then over here you would do 2 times 2, so you're going to do the same thing here. 3 times r, which is 3r. And we're going to put a plus sign here because of the pluses. And then you would do 4 times 3, so we're going to do the same thing here. 3 times r, which is 3r. And then we're going to do, what you would do over here is 2 times 4, so we're going to do r times r is r squared. Now notice that I stacked them 6r and r squared. So that's our c squared. So we've got r squared plus 6r plus 9 is equal to 9 squared, which is 81, plus r squared. Now, this looks like it could be a quadratic, but when you subtract r squared from both sides, it cancels. And so we're going to move our 9 to the other side, and we get 72 on this side, and we have 6r over here. So we divide both sides by 6, and we get 6 times 12 is r. So r is equal to 12.